Hey guys, welcome to the 83rd C programming tutorial, and in this tutorial we're going to be talking about the binary search algorithm when searching through integer arrays. In the next tutorial we'll get into making this search algorithm generic, but for right now let's just talk about what the binary search algorithm actually is. So one thing that you really need to know about the binary search algorithm is that all the elements inside of the input array have to be in sorted order. For right now, we're just going to assume that all the elements are already in sorted order, but later down the road in this tutorial series, we'll actually get into sorting algorithms. So let's actually talk about the algorithm itself right now. So the first step in the algorithm is to go to the middle element inside of the array. So since we have an even number of elements in this array right here, we'll just say that our middle element is 12. The next thing that we have to do is compare this middle element to our key. If the middle element right now is the key, then we just return the current index. So our current index would be 3, since 12 is at the index of 3 inside of this array right here. However, our key is not 12, our key is 19. So the next thing that we need to do is say if the key is less than the middle element, look left of the middle. Well, is the key less than the middle element? No, it's not. Our middle element is 12 and our key is 19. So the key is greater than our middle element. So what we need to do is actually look at the elements to the right of our middle element. So now we're only looking at these elements right here. And that would be this step right there. And then we just need to repeat. So now we go to the middle element again, but instead of going to the middle element inside of the entire array, we just go to the middle element inside of these numbers right here. Since we know that our elements are already in sorted order, and we know that 19 is greater than the middle element, that means that 19, our key, if it's in the array, has to be on this side of the middle element. It has to be on the right side of the middle element, so we don't even have to worry about these elements over here. We're only looking at these elements. So now we just need to find the middle element of these four end elements right here. And the middle element of these four is 19. So is 19 our key? Yes, it is. So we just stop right there and return the index that 19 is at. So now let's actually look at a bigger example. This example right here will be a little bit closer to how we're going to be writing our algorithm. So inside of our algorithm, we're going to be having three main variables. Our first variable is going to be called low, and that's just going to store the index of the bottom element. And then we're going to have a variable called current index, or current element, and this will just store the index of our middle element. And then we'll have another variable called high, and this variable called high will just store the index of the last element that we're looking at. And in order to calculate current, all that we do is we add together high and low. So we add together 9 and 0 and then divide it by 2. Since high's value is 9 and low's value is 0, so 9 plus 0 divided by 2 is 4 in integer land. So our current index is 4. So now what we have to do is just compare the key to the element at the current index. So is our key 17? No, it's not, so that means that we have to look either to the left or to the right. Is our key greater than the middle element? Yes, it is, so that means that we need to look to the right. We need to look at these elements right here. So what we're going to do is, since we're not going to be looking at these elements anymore, we're just going to make our lowest element this element right here. It's going to point to 18, so it's going to be storing the index 5. So it's going to look like this. So again, we have to calculate our current index value, and in order to do that, we just add together low and high. So we just add together 9 and 5, and then divide that by 2. 9 plus 5 is 14. 14 divided by 2 is 7. So our current index is 7. So again, we have to compare our middle element to our key. So we compare 24 to our key. Is our key 24? No, it's not, so we need to move either to the left or to the right. Well, our key is less than the current element, so that means that we need to look at the elements on our left. So the only two elements left are 18 and 20. So this is what it'll look like next. So our low value is the index 5, and our high value is the index 6. And again, we have to calculate our current index, so we add together 5 and 6 and divide that by 2. 5 plus 6 is 11, divided by 2 is 5 when we're doing integer division. So again, we compare the element at the current index to the key. So we compare 18 to our key. Is our key 18? No, it's not, so that means that we need to look at the elements to the right of our current index. and that leaves only one element left. Now everything is looking at the element at the index of 6. So again, we have to calculate our current index, so we add together high and low, so 6 plus 6, and then divide that by 2, which gives us the current element 6. Now what we need to do is just compare our element at the current index to our key. Is 20 our key? Yes it is, so we stop right there and return our current index, which is 6. But let's say that our key was something different. Let's say that our key was 21 and we hadn't found it yet. Where do we go from here? Well, we would make low be the index after the current index, so low would be 7, and we would make high the one before the current index, so high would become 5 and low would become 7, so it would look like this. And at this point, when low is greater than high, that means that our key is not inside of our array. So if our key was 21, then it would look like this on the last iteration, and we would have to stop because when low becomes greater than high, that means that our key is not inside of the array and we need to return -1. Alright, so with all that information, this is exactly what our binary search algorithm would look like. So we have 3 variables at the top right here. We have low, which just stores the index of our bottommost element, and then we have high, which stores the index of our topmost element, and then we have current index, which just stores the index of our middle element, or our current element, however you want to think about it. And then we're going to be looping while low is less than or equal to high, because when low is greater than high, that means that the key is not inside of the array and we need to return -1 to tell the caller that their key isn't inside of the array. So the first thing that we do inside of our loop is we just calculate the current index. We just add together high and low and divide by 2. Then what we do is we compare the key to the element at the current index. If we found the key, then we just return the current index. Otherwise, if our key is less than the element at the current index, that means that we have to look at all the elements to the left of our current index. So we make high the element right before our current element. And the exact opposite would happen if key is greater than our current element. So we would have to make low the element after our current element, so that we're only looking at the elements to the right of our element at the current index. So now that you understand the binary search algorithm, let's go ahead and compare the binary search algorithm and the linear search algorithm. So the linear search algorithm has a couple upsides. It's really easy to write, and the elements can be in any order at the start. While the binary search algorithm is a little bit harder to write and the elements must be sorted, it is much faster than the linear search algorithm. As you can see right here, I ran a few tests. Basically what I did is I created an integer array with 100,000 elements in it, and then randomly filled all those elements with random numbers in between 0 and 100,000. And then I just searched for a random key using the linear search algorithm and the binary search algorithm. And these numbers right here are just how many iterations it took in each algorithm. As you can see, it took many more iterations in the linear search algorithm than it did in the binary search algorithm. The linear search algorithm on the first try took 10,000 iterations, while the binary search algorithm only took 10. And then as you can see right here, it's pretty much the same. And then the one at the bottom just represents what would happen if the key is not inside of the array. So if the key was not inside of our array, there would be 10,000 iterations for the linear search. You'd have to go through every single element to make sure it didn't find the key. But the binary search only had to do 10 iterations, since it just eliminated so many elements at once. Alright, so that's pretty much it for this tutorial on the binary search algorithm. So see ya guys.